Hey everyone, in this video let's take a look at type guards and type predicates and why they are incredibly important. So for this I have this file which is for internationalization, and all it does is take in a locale which is of type string, and then based on this locale we return the corresponding messages, so the internationalized messages. So for this I have a directory, messages, and then I have the English and the Spanish JSON files. So just to contextualize, I have this English JSON file, so it contains the content for my website, and the same for the Spanish one. And these are the only two languages that I support. So I have English and Spanish here within this array. Now for this I'm using asConst, which is going to narrow down the type for this variable. So TypeScript knows that this array only contains these two, so English and Spanish. Hence, when we use asConst, it knows that the type is a read-only tuple, where the first element is English and the second one Spanish. So for this, I can declare this type locale, and then all I need to do is say type of locales, which is going to give me back this read-only tuple type. And then I can use this indexed access, and then I can say number, and this is going to extract each element. So we get back a union of English and Spanish. But then I have this message imports object map, where the keys are of type locale, so we can only have English or Spanish in this case. And then the value for each key is simply a function that returns a promise that contains a property default that is of this type, which is simply going to be an object where the key is of type string, and then the value is either of type string or recursively the same type. So as you can see here, we have the key value pairs, where each value is either an object with keys that are strings or just strings. So with this in mind, I created this function, isValidLocale, and we take in the locale which is of type string. Now here's the interesting part, and that is the locale that we pass in might not correspond to either English or Spanish. So it can be the E or it can be whatever else. So for that, all I do is use.sum, which is going to return true if one of the elements satisfy this predicate, so where the locale is equal to the one that we pass in. So we just return a boolean, true if the locale is of type locale and false otherwise. But here's the problem. So we get the base locale, so we just say new intel.locale, we pass in the locale, and then we get the base name. This is so that we do not get something like NUS, for example. So this will be extracted into English, which is the base locale. And then we have this class guard. So we check if not is valid locale, then just invoke this function not found. And this comes from Next.js. It is simply going to return a 404 to the client. And well, it uses this never type, so that it is similar to throwing something. It is going to bail out of the execution of this function. And I can confirm this if I copy this and paste it here at the top. As we can see, all of this code is unreachable. So in fact, if we create our own function, might not found, and we throw an error and the return type is never, as we can see, if I say might not found, then all of this is unreachable. And the reason is because we're using never. So this is a way to leverage the never type in TypeScript to make sure that if this is invoked, that means that you're throwing an error. So it makes sense as to why you would use never in this context. Anyway, so at this point, at line 20 and onwards, we know that base locale is of type locale. Because again, if this is true, then this is of type locale. But TypeScript doesn't know that. So when we say await, message imports, and then we pass in the base locale, as we can see, it is still of type string. So we need to assert it to be as locale. And in fact, if I remove this type assertion, as we can see, we get this error, unsafe assignment of an any value. And the reason is because we're doing this dynamically. When we pass in a string, the value may not exist at all. So as far as TypeScript is concerned, if we pass in a string, then you cannot index this object, since we know it can only have English or Spanish. So that's why we get this error. So the solution is to just assert this and say, okay, well, this is a locale, and now TypeScript stops yelling at us. But there's a better way to avoid doing this, because this is redundant. First, we're checking if it is a valid locale, and then we need to use this class guard, and now we need to also assert the type to be locale. That is so unnecessary. Fortunately, if we use type guards, which are like class guards but for the type level, then we can avoid this altogether. So we can say locale is and then locale. So this is the type predicate. So if this function returns true, then TypeScript knows that this parameter that was passed in is of type locale. Otherwise, well, it isn't. And so we can bail out right away. So this way, as we can see, the error went away. And if we take a look at base locale, starting from this line, then it is of type English or Spanish. So this is why type guards are so important. And whenever you find yourself asserting the type after a class guard, make sure to refactor that, if possible, to a type guard instead. So let's take a look at another use case. So this is for handling TRPC client errors. So when the server in TRPC throws an error. For this, the error might contain a code. And the code is, well, the representation of the status code. So it could be a bad request, a forbidden internal server error, etc. But since it might contain it, we cannot always access this property. So what we can do is declare this interface, we extend the TRPC client error interface, and then we extend it with this. So we say data, and then the code is TRPC error code key. And then we can define this function is TRPC client error with code. It takes in an error which is of type unknown, and then we can say error is TRPC client error with code. So this extended interface. And here we have some basic checks. So if error instance of TRPC client error, which is the base one, because it extends from it, and if the type of error.data is equal to object, then we can get access to the potential error with code. But then we need to check that the code exists. So we can say code in. So this is going to check if a property exists in an object. And then we have, and the type of is of type string. And if all of this is not true, then just return false. That way, we can say if is TRPC client error with code, we pass in the error, which at this case is of type any, or better yet of type unknown, then we get access to data, and we also get access to code. So the great thing is all you need to do is create a type guard function. You specify the type predicate, and then you can be rest assured that if this yields true, then that value is of this type, simplifying your logic a lot and also minimizing redundancy. So this wraps up the video. If you want to see more content like this, make sure to like the video and subscribe. I'll see you in the next one.